with tension and mystery. There might be something out there so extreme, so powerful, so utterly alien that it could kill a black hole. Not by brute force, but by being stranger than even a singularity. Meet graver stars, cosmic soap bubbles made of pure energy, wrapped in a shell so dense and cold it makes black holes seem warm and gentle. They might be one of the universe's best-kept secrets, or just a fever dream of theoretical physics. So, what are gravastars? What do they look like? And if they exist, could they rewrite our entire understanding of reality at the birth of something stranger than a black hole? When massive stars die, they don't go quietly. They go supernova, detonating with a brilliance that can outshine entire galaxies. At their heart, their core collapses under the weight of its own gravity, triggering one of two known outcomes: a neutron star, compact and dense, or a black hole, where matter is crushed into a point so dense it tears the fabric of reality, creating a singularity. But what if there's a third option? One even weirder, a scenario where the collapsing core doesn't become a singularity. Instead, it gets ground down so hard that matter itself ceases to exist, transforming into raw, violent energy. This isn't science fiction. This is the theoretical birth of a gravastar, where expansion meets collapse. Imagine the core of a dying star being crushed into a miniature Big Bang. A bubble of pure vacuum energy trying to expand smashes into the collapsing outer layers of the star. The result? A clash of cosmic titans, gravity crushing inward, energy exploding outward. The battle for dominance creates something new, a hyper-thin, ultra-dense shell forged at the edge of what's physically possible, trapping the expanding bubble forever. And just like that, a gravastar is born. Nor one does a gravastar look like. From the outside, a gravastar looks almost identical to a black hole. Same massive gravitational pull, same warping of space and time, same eerie darkness. But the resemblance ends there. The shell of a gravastar is colder than cold, just a billionth of a degree above absolute zero. It's so cold and dark, even the cosmic microwave background shines brighter by comparison. This shell isn't made of atoms, it's made of exotic matter, materials so extreme and dense that a single meter of stretch would take the energy of a supernova. Inside, nothing, literally, but also everything. The core of superdense, nothing. To understand the inside of a gravastar, we need to rethink what nothing means. In quantum physics, what we call nothing, the vacuum, is actually a sea of fluctuating energy. Particles are just waves in this invisible ocean. Even in empty space, this fluid hums with potential. Now imagine compressing this vacuum to its ultimate limit, squeezing the energy of the cosmos itself into a tiny bubble. This is what's inside a gravastar. Not matter, not particles, just an unimaginably dense, pressurized vacuum. It's the most energy you can pack into space without ripping the laws of physics apart. And it desperately wants to expand, but it can't, because it's sealed inside the toughest, coldest shell in existence, an eternal standoff. So, is this real, or just a mind game? Here's where it gets really exciting. Gravastars solve some of the most troubling paradoxes of black holes. No singularity, no information loss, no tearing of space-time. They could be the answer to physics' biggest headaches, but they also introduce new mysteries. What is this exotic shell made of? How can nothingness hold so much energy? Still, just like black holes once were, gravastars work on paper, and we might be closer than ever to finding out if they're real. Echoes from the cosmos. Listening for gravastars. There's one key difference between black holes and gravastars. Black holes have an event horizon, a point of no return. Gravastars have a physical shell. This means they behave differently when they collide. Black hole collisions create short, sharp, gravitational wave signals like a quick bass drum. But two gravastars colliding, that should echo like a gong, subtle ripples stretching out in space-time. Physicists are already listening to these gravitational echoes, but the signal is faint, like trying to hear whispers through concrete. Our instruments aren't quite there yet. Point. Why this matters. Are gravitar stars real? Maybe. Maybe not, but that's the beauty of science. Black holes were once just weird equations. Now we have images of them. Gravitar stars are the next idea to chase, the next mystery to solve. They might be wrong, or they might change everything, because that's what science is about. Not answers, but better questions. A universe that's stranger and more beautiful than we ever imagined.